Hello everyone. In this lecture we will discuss field produced by magnetized object. For this suppose here we have a magnetized material and suppose here this is a volume element and here suppose this is a one dipole having magnetic moment vector m, and we are interested to find the vector potential at a distance vector r. Then the vector potential this equals to mu naught over 4 pi, and here we have m cross r cap over r square. So this is a vector potential for a single dipole. So here in terms of volume integral, this vector potential is equals to mu naught over 4 pi, and here this is a capital M vector r into r cap over r square. So here small m is the magnetic dipole moment and capital M is the magnetic moment. Here capital M is the magnetic dipole moment per unit volume. Or we can say magnetization. Okay. So capital M is the magnetic dipole moment per unit volume or magnetization. So here the gradient of 1 by r, this is equal to r cap over r square. So now we can write above equations as this, that is vector a r equals to mu naught over 4 pi, and here we can write m vector r cross gradient of 1 by r, and here we have a volume integral v. Okay, now here we will use to solve this we will use the vector identity. So here vector identity is, that is del cross FA equals to F del cross A minus A cross del F. So by using this vector identity, we can write above equations as this, that is A R equals to mu naught over 4 pi, and we can write 1 over r. Here we will use the integral, and this is equals to del cross mr dv minus del cross m r over r dv. Okay, then here we have a volume integral, so we will convert this volume integral into a surface integral. So for this we can write mu naught over 4 pi. Here we have 1 over r del cross m r dv minus here we will use plus sign, mu naught over 4 pi. Here we have a closed integral, so this is a 1 by r, so this is a m r cross dA, that is a surface integral. Okay, so now here this first term, that is del cross m, this is equal to jb, that is this is the volume bound current, and second term, that is m cross n cap, is equals to kb, that is this is a surface bound current. So here first is the volume bound current and second is the surface bound current. So finally above equation we can write like this, that is AR equals to mu naught over 4 pi. So here this is a JB over R, this is a function of R dV, and here this is a mu naught over 4 pi, here this is a KB function of R over R dA. So finally a vector potential, or we can say field, produced by magnetized material is equals to this. So here we can say the vector potential or field is the sum of the what we have, this is a volume bound current and the surface bound current. So here JB is the volume current through the material, and KB is the surface current on the boundary. Okay, so finally the vector potential is the sum of volume current and the surface current. So here JB is the volume current through the material, or we can say throughout the material, and KB is the surface current on the boundary. Okay, thank you.